Talk about pages 17 through 20. Hopefully you did well on your checkup. Page 17 and 18 actually is a flashback to Algebra 1 and a little bit of Algebra 2. We've done this before, taking two equations and solving by elimination or addition, where you multiply everything through by a number and then you get one of the variables to cancel out, like maybe getting rid of the x term, and then you solve for y. Once you know what y is, you can go back and solve for x. They show all the steps involved. You know how to do this, okay? Study the example, and then you come up with an x and a y value, and that is an ordered pair. Turn the page. Page 18. Ha! You have a whole page of doing that kind of a thing. This should be a review. Now they're building up to something, because they're going to show you a method then, which I'm going to go on now and teach, okay? But if you want to stop and just go ahead and do 17 and 18, you can do that and then turn it back on, and we'll talk about 1920. But on page 1920, we're going to use determinants, which we just learned about before the checkup, to quickly and easily solve to find x and y. And again, this makes it easy for a computer to be able to solve equations by elimination, because all we have to do is know what the numbers are to plug into the matrices, and boom, the computer solves it, okay? I left this up here just to remind us that for determinants, we multiply this way, a1, b2, and then we multiply the a2 times b1. This one's negative, this one's positive, and you add the positive plus the negative one, and then you get one number, okay? Let's talk about how we're going to do that to solve, and again, I'm on page 19. Now here on page 19, they go through all the explanation, and it'd be good to read through that. I'm not going to go through that right now in the video, but they show where all of these, you're taking the opposite, and you know what, after you've done the previous page, page 18, and now you look at this and imagine the numbers that are in there, you're like, oh, I see what they're doing. So they're taking the a2, which is the coefficient on the second equation, a2x plus b2y plus c equals c2. They're taking that coefficient on x, changing it to its opposite, multiplying everything in the top equation by that, taking the positive value of the a1 from the top equation, multiplying everything in the second equation by that. Okay, and that's how they get this c. And then when you add those together, miraculously, the x term is gone, okay? Just cancels out. So what they have underneath here is a1, b2y added to or minus a2, b1y, which is this one right up here. So these two put together, and then you have these two put together over here. And then to get the answer, you factor out the y, and you're taking this divided by this, okay? Then they jump to the conclusion that this can actually be written as a matrix, okay? And this can be written as this matrix. And then we can solve it using the rule for determinants and get our answer, okay? So let's use this new interesting method to solve this one. Where's my black marker? Here we go. Now they explain that for x, we're going to use the c1, c2, b1, b2. This is our denominator. Y is this. The denominators are the same, notice, okay? a1, a1, a2, b1, okay? Same. Where are we going to get a1, b2, where are these numbers coming from? All right, let's look over here. This number is a1. The -2 is b1. The 4 is c1. This coefficient is a2. This coefficient is b2. This coefficient is c2. That's it. Okay? So let's solve for x. So notice that these lines don't have the little, they don't come in and then back again. They're not brackets. like this, okay? And that indicates determinant. If it has, otherwise it's called a matrix. This is a special kind of matrix, the determinant. So let's see, what's our code here? We're going to do C1, which is 4, C2, which is 6, B1 is -2, B2 is 9. Okay, the denominator is 3, A1, and 3 down here. B1 is -2, B2 is 9. See where I got all that from? All right, let's go ahead and do Y. All right, so we have a determinant on the top. The bottom, for this one, we're going to do A1, A2, C1 is 4, C2 is 6. A1, A2, B1, B2. And now, the magic. We just cross multiply, so this times this is 36, this is -12. And now we're going to add not 36 plus -12, we have to change this to its opposite, the opposite of -12, which is +12, and then we add that, so we get 48. All right, what does this give us? 27 and -6. And then we have to change this to the opposite of -6, so +6. 27 plus 6 would be 33. All right. This one should give us the same thing. I probably don't even need to do it. It's going to be the same as that, so this denominator is going to be 33. All right, let's do the numerator up here. 3 times 6 is 18, 3 times 4 is 12. And then we do change this to its opposite, and we get -12. So 18 plus -12 is 6. That we can reduce, so 2 over 11. This one we can reduce by 3. So this would be 16 over 11. So we would say the answer is 16 elevenths, comma, 2 elevenths. Now, I say I made that one up. I actually copied page, all right, let's see, page 18. This is not one you're doing for homework. This was one you did in the other problem. Yes! All right. On your score key here, page 8, this was one of the problems you did where you used the old method from Algebra 1 and Algebra 2. And look, the answer is 1 5 elevenths, which is the same as 16 elevenths, and 2 elevenths. So we used determinants to get the same answer that you could do using that old, long method. Isn't this the cool thing about math? You can do it multiple ways and always get the right answer. As long as you do it correctly, which we did. All right, I would highly recommend that you write this down on a cue card, either a Post-it note, a 3x5 card, and keep it with you. Follow this. This is the magic formula to use in order to solve the problem. And, you know, it wouldn't be a bad idea to write this down, put this on the back of the card, you know, and just to remember that this is negative, this is positive. And then you have a few problems to do here on page 20. And I think you will do well.